Hi, welcome to my long ISP, the 8-bit audio player. As the name suggests, this ISP is able to play 8-bit audio files. So here's a quick demonstration of its features. The bottom of the device contains the ports, which is a USB-C port for power, and a headphone jack for audio output through headphones. Also, input is provided through this rotary encoder, which is here, and this is just a 3D printed knob for the rotary encoder. So here's a quick demonstration. If I plug it in, it will first show all the songs, and you can scroll through to select more songs. The songs are on the SD card, and they can be updated by popping this card out and placing more songs on it. So whichever song is at the top is the song that's currently selected. So if I plug in these headphones to the headphone jack and I'll select the song, it'll start playing. So a progress bar shows up and the current number of elapsed seconds and the total number of seconds show up, as well as the name of the song. So if I hold the headphones to the microphone, you can hear the audio. At this point, the user has two controls. They can toggle playback by selecting, or they can go back to the main menu by scrolling, and playback will continue in the background. The final feature of the audio player that I'd like to highlight is the Load More button. Due to memory constraints, the MCU only holds 24 to 25 song names in memory at a time, so to go to the next page, there's a Load More button, which loads the next page. So if I click on it, it loads the next page, which has, in this case, 4 songs. So with that, let's get into how this device works. Here's what the device looks like without the cover. It's essentially a PCB with a screen breakout board attached, and the screen breakout board also has an SD card slot. For reference, this is the PCB that is powering the audio player. The first thing to note is that there are actually 2 microcontrollers. One player microcontroller and one controller. This means that the 2 MCUs need a way to communicate with each other. The main way that this is done is by setting Boolean flags and sending values over I2C. On the most basic level, the player MCU waits for a flag to be set by the controller and then waits for a song number. Finally, it plays the song corresponding to the number set by the controller. So this is the diagram of how the audio file is converted from a file on an SD card into an intelligible sound. Essentially, the digital samples are read from the SD card and stored into memory on the MCU. Then these audio samples are put onto an R2R ladder, which is an example of a digital to analog converter, and this converts these discrete samples into a low amplitude audio signal. In this stage, the audio signal has a very low amplitude, but the important thing to note is that the proportions of the peaks and troughs of the signal are correct. To boost the amplitude of the signal into something audible, the raw signal is fed through an amplifier, and then it's converted into a similarly shaped, larger amplitude signal. This signal is then directly sent to headphones out of the audio jack and is perceived as sound. So the specific way that the ATmega 328P plays the audio is as follows. First, the first 256 bytes of the audio file are loaded from the SD card into a 256-byte array. This array functions as a buffer. At the same time, a timer will interrupt with a frequency of 16 kilohertz, which is the sample rate, is set up. This interrupt service routine simply increments an index. Then, in the loop of the code, the value of the current index is simply placed on port D, which is attached to the R2R ladder. Then, each time it gets to the end of the array, it reloads the buffer. This reload process occurs around 63 times a second to achieve a sample rate of 16 kilohertz. Thank you so much for watching. I hope you enjoyed this ISP presentation.